Example 3, convert each polar equation into a rectangular equation. Okay, because we did so much in example 2, we did more than what was required in example 2. This example 3 is just going to be so easy for you guys. All right, so just like before in example 2, to convert this r equals 3 divided by 1 minus sine of theta to rectangular, we would cross multiply. You can make it over 1, cross multiply. So that would be r minus r sine theta equals 3. Now, just to double check, okay, you want to find your e value and then write somewhere on the side, especially if this is a test question, that it's a parabola. The reason is that when you are converting it back to rectangular, if it's a parabola, only one of the variables is being squared. Okay, so that's a mental check for you on a test or on your homework. All right, r is going to be the square root of x squared plus y squared. R sine of theta is going to be y equals to 3. Now move the y to the right before we square both sides. That would be 3 plus y. Now we would square both sides. So that would be x squared plus y squared equals, FOIL this out slowly and correctly, that would be 9 here. This is going to be y squared. In the middle, you're going to have 6y. Well, y squared and y squared, we are going to cancel that out. Now, let's see if we can put this in standard form. X squared equals, take out the 6, and then y plus, if you take out a 6, it's 9 over 6 in here, but 9 over 6, reduce that to 3 over 2. So this is the standard form of your polar. Now, as you can see, only one of the variables is square, so it is definitely a parabola. And you know it's a parabola because then you know you did it right. Okay, so check that off. And I feel like we did something like this already. Oh, look, that's the same thing as example 2b. Okay, except the 2b, I gave you it in cosecant. But look, once it's converted out to sine, it's the same thing. All right. Okay, now let's find the e value. Okay, to find the e value, what you want to do is divide both sides by this, because it has to be r equals in polar. Okay, so now we would get r equals 2 divided by 2 minus cosine of theta. This is so that we can check it. This is not in standard form, students, so make sure we multiply this by 1/2. What we multiply to the bottom, we would multiply to the top. So r equals, now the top is 1. This is now 1, and this is now a half. All right. Now e is a half because it's right here in front of cosine. Since e is a half, that's less than 1, so we know this is an ellipse. And we just want to check it, okay, to verify. So when we convert it into rectangular, you have the x is square, the y is square, and there's a plus sign in the middle. All right, let's see if that will help us check our algebraic work. All right, so now let's go and get a different pen here so we can do our work. Okay, now we don't, from the original, we do not need to cross multiply because it's already in a nice form for us, but we do want to distribute the r, so that will give us 2r minus r cosine of theta. So from here, it's going to be 2 square root of x squared plus y squared, and r cosine of theta is just simply minus x. We do want to move the x to the left side before we square both sides to get rid of your radical. Now go ahead and square both sides, just like that. This is 4 plus 4x plus x squared. This will give us 4 times the quantity of x squared plus y squared. Distribute that out on the right side. I'm just going to copy the left side back. This is going to be 4x squared plus 4y squared. Okay, let's try to combine like terms and then try to see if we can complete the square. So 4 equals, I'm going to move all of the x's and the x squared to the right side. Okay, move that over and move that over. So if we move the x squared over, we would now have 3x squared. If we move the 4x over, it's now minus 4x plus a blank space. Drop down your 4y squared. Now we can't technically complete the square unless the 3's factor out. So let's factor the 3. Okay, we don't need to complete the square for the y. We're just going to copy that straight up. So this is x squared. We take out a 3. So this is now 4/3 x plus a blank space. And remember, we want to do half of 4/3. Okay, half of 4/3. That means we're going to take 4/3 times a half. So reduce that. We're going to get 2/3. Okay, so half of 4/3 is 2/3. And we want to square it. So that's going to be 4/9, and that goes right here, 4/9. Well, we add it to one side. We got to go and add it to this side, 4/9. But this 4/3 is being multiplied by this 3. So we want to multiply this by 3 as well. Okay. So now I'm going to go down here since I want to save this to see what we need for later. So we got 3, reduce that down to 4/3 plus 4 equals 3 times, let's factor this out, x minus. Remember when we took a half? Whenever you take a half, that's right there. We're going to need it for factoring, and that goes right here, just like that. And then plus 4y squared. Okay, so common denominator is now 3. This becomes a 12. So that's 16/3. So 16/3 equals 3 times x minus 2/3 squared plus 4y squared. Now we have to make sure it equals to 0. So what we want to do is divide each and every term by 16/3, just like that. Okay. All right, so cancel, cancel. That will give us a 1, which is what we want. 1 equals. Now, as you can see, if you know how to do this pretty quickly, you can just go straight there. To get rid of that, I want to multiply by 1/3. To get rid of the 4, here we multiply by 1/4, just like that. So that would give us x minus 2/3 quantity squared over 16/9. Leave it, and then plus y squared all over. We can reduce this right here. That's a 1, that's a 4, so that's 4/3. All right, so that's our rectangular form, and leave it in that format, because that is your standard form of our ellipse. Now let's quickly check, okay, a couple of things. Okay, do we have both x and y squared? Yes, so we know it's being closer to an ellipse, and there's a plus sign in the middle. So we have 2 variables squared and a plus sign in the middle, so we know it's an ellipse, which matches our E value. Hey guys, all right, this is 10.6, example 4. Find a polar equation of the conic. It has a focus at the pole. Now E is 2/3, and the directrix is parallel to the polar axis 3 units above the pole. Okay, so since E is less than 1, we know that this is an ellipse. Okay, so we know this is an ellipse. Since we know it's an ellipse, it also tells you that this directrix is parallel to the polar axis and 3 units above the pole. So we know P is 3. Our equation is R equals E times P divided by 1 plus E times sine of theta. Now the reason we know sine of theta is because of the directrix. The directrix is parallel to the polar axis. Okay, so if you don't remember that, we want to go back up. Here we go. If the directrix is parallel to the polar axis, okay, then we want to use sine. Okay. All right, so here we go. Well, we know what P is. Okay. So, and we know what E is. Let's try to plug some values in. R equals, E is 2/3, P is 3, so that's on the numerator. Then we have 1 plus E, again, is 2/3 times sine of theta. Then from here, we just have to get rid of the fractions or simplify that out, okay? So we got 2/3 times 3. That will leave me a 2 on the top, which is a nice number. On the bottom, though, okay, we want to get rid of this fraction, okay? So that way we're consistent with E not being any fractions right there. So that's easy enough. We're just going to go multiply each and every term by 3. So to get rid of fractions, we multiply the common denominator. When you multiply to the top, you multiply to the bottom. So I believe this will do it. So 2 times 3 is 6 divided by 3 plus 2 sine of theta. And this is as far as you can go. So right now, that has no fraction, which is normally what we want, okay? And that's the end of this note.